Hello, I'm Tim Cook with Cook Saw Manufacturing. We're a family-owned company that manufactures sawmills. We manufacture saw blades, and we manufacture sharpening equipment. We've been in business for about 35 years in the sawmill repair, saw blade repair. Started off in the business doing the circle saws, up to 72-inch diameter circle saws for the large sawmills, and we work with the small mills. We prefer to work with the small mills at the present time because we just like the people. We just like dealing with people that are in the woods and sawing lumber all the time. They're just our kind of people. But it's a family-run operation, and my brother and I are real active in the business. My mom and my dad's retired out, and my mom helps some there in the office on a regular basis. But we've got some really good workers that work with us in our company. We've got strong help. We build a very good product. I'm here today, I'm going to show you our AC-36 sawmill. I'm going to show you why it's a good mill. I want to show you some of the things that it takes to saw accurate lumber with a bandsaw. We've been building these sawmills for about 15 years. We are known as the leader in the industry in technology. We're a small company. We can change fast. We can discover new technology through experimentation, and we do. We continue to experiment. We continue to serve our customers. We help people from here to Canada understand how to saw better. Actually spend more time troubleshooting on the phone the other makes and the other products out there in the market, helping people understand how to saw with them, than I do spend troubleshooting my own products. But we give service after the sale. This is a great thing for people who buy a sawmill. When you get a sawmill and you have a problem, you need help, we know how to solve it. And there's not a problem out there that we can't solve when it arises, whether it be our mill or other mills. But the main thing I want to concern myself with here today is the mill that we build. We build a very heavy mill. It's a very strong mill in the class of mill that we're building in this class of mill. One of the biggest things I want to show you today, and one of the most important thing, is the band head. On our band head, this particular mill, the AC-36, uses 26-inch diameter wheels. The rim is solid steel. You can see the thickness of the rim is about 1 inch thick this way. It's about 1 3/4 across the face of the wheel. We mount these wheels and we grind them. For instance, the idle wheel has a bearing inside, and we grind this wheel true on the rim. We grind the crown into the wheel. So we have a perfectly true wheel. On the drive side, we mount it onto an accurate shaft. We spin that wheel and we grind that wheel true. This is the heart. When we're talking about what makes a bandsaw mill cut, if you look at the bed down here, this holds the log, this turns the log, it handles the log. But if this part is not working, all of this is scrap iron. And I frankly don't like to build scrap iron. I don't like to sell it, and I don't like to see a customer who has it. I want a man that's, I want to sell a mill that you can saw with. I want to sell a mill to somebody who, when you're ready to cut production, you're cutting production. And so this is the heart. This is what's important. We have heavy roller guides so that we can control the blade. We can make that blade stay where we want it to be. As we're considering what this bandsaw head needs, there's 5 rules. I write articles about this and I try to help people understand them. It is, number 1, the blade must be sharp. Number 2, the blade must be set enough to clear the blade. Number 3, the blade must be flat. Number 4, the guides must hold the blade straight away, never leading up, never leading down, and they must be rigid. They can't be wiggly and wobbly. They got to be very rigid. And then number 5 is the band wheel alignment. Whether it be straight up square, whether it be leaning forward or leaning back, you have to have this range of adjustment so that it can be tuned out so that blade's least path of resistance is straight away. And I'll tell you today, whether your logs be frozen, whether you have hard knots, whether you're sawing white pine with hard knots, whether you're sawing hard maple with hard knots, you can saw straight through the knot. It is easier to saw straight through the knot than it is to saw and the blade rise at the knots or dive at the knots. Now, the technology to that is understanding the mill, understanding the blade, and having a mill that will adjust in such a manner until the least path of resistance is straight away. But with our good solid wheels, a good solid frame, good roller guides, you put a good blade on it that's flat, it will saw straight away and it will saw fast, and you can get your production on a daily basis. This is the heart of the operation. While I'm here, I'm going to show you that we've got a debarker. We call it a debarker, mud saw. I really prefer to call it a mud saw. It's got carbide tips on it, and you can cut the mud out. It's right in line with the saw blade, and so it cuts the dirt out of the way. The bandsaw blade don't hurt to cut wood. In other words, the teeth love wood. They'll eat the wood, but dirt is a bad thing, and so this thing will cut the dirt out of the way. This is available on our AC-36 with the 62 horsepower mill and the AC-36 with the 51 horsepower mill. Now, I want to pause here and go into a little bit of blade technology, a little bit of guide technology, so that you can understand what it takes, and you can understand what we put into this mill so that we've got a mill that will do well. First of all, I'm going to show you a blade guide tool, and I'm going to show you this on a 2-inch wide band. And what I would do is I would actually put this under the band as if it were on that mill over there. And I'm going to slide this in, and then I'm going to tighten it up underneath. And of course, I'm going to make sure I'm not on a tooth. Across the gullet is a good place to be. Now, what this tool does is I can measure from here down to something that's flat on the bed of the mill. You can use a level, but do not use the bubbles. We never use bubbles when we're leveling a bandsaw blade. We use parallel measurements. I want to know where it is exactly. And as you can see, if I were to tilt this blade down, this indicator is magnifying what is happening here at the blade. And if I'll turn it a little bit, but if the blade is tilted up, this indicator is going to show me. What I want is this blade to be straight away. I don't want it to be leading up, and I don't want it to be leading down, none at all. And it only makes sense because when we consider the teeth, one of these teeth is bent to the right, and one of them's bent to the left, and then you have a straight tooth. These teeth then are to cut the gap so that the blade can pass through the gap without touching. And so I'm going to simulate that with my fingers. If I cut a gap, I want to be able to slide through dead down the middle, right down the middle with that blade. Of course, we're only putting 20 to 25 thousandths on the side, according to which blade you're using, and the same thing on this side. So it's a small gap. We can't afford to send that blade down the cut leaning up nor leaning down, and you can see that magnified with that 2-inch blade. Now, the other thing that's important with bandsaw blades, and this is overlooked in the industry, this is a technology that Cook Saw Manufacturing came up with. I actually was the one who came up and started to understand it way back in the early 90s, and I've been doing it ever since. There are some people out there that say the flatness of the blade don't matter, and they just don't understand the technology that it takes. Now, what we want is to know that our band is flat. Now, what I've got is a straight edge razor that comes out of a utility knife. This is one of the best things to use. Get you a new pack of them. You can check across the width of your blade. You can tell how flat that blade is. And at the guided area in the straightaway is the only way you can check for flatness. You're going to put it across the width, and you can see the light. Today we've got a nice sunshine coming in from the east, and I can see the light. Now I'm going to see if you can see the light under this. Now what I'm going to show you, when you bend this blade, the outer edges go up like this, and it leaves a dish in the middle. I'm going to see if the camera can pick that up. Can you pick that up? All right, now there is a dish here is what we're seeing. There is a dish. All right, now I'm gonna turn this blade inside out and turn it back over, and you'll see a dish again if I can get that lighting right. Now, if you can't see it on the camera here, then grab a blade sometime, grab a flat piece of steel, bend it into a circle, and what you're going to see is the outer edges are dished like that. Use your straight edge razor.